All right, welcome to another VEX lesson. This one is Activity 423, Moving with Color, and my name is Gabe Valdez, and I welcome you to my video. I'm going to be walking you through this activity using VEX V5. We are going to explore, as I scroll down, a couple of things. One, we'll start off by looking at the servo motor. And then another thing we'll be looking at as we move on is the optical sensor. And we're really going to dive in deep and based on some optical sensor feedback, make some different actions occur regarding the servo motor and also some LEDs as well. Right. We are also going to use the VEX smart motor once we get into step number 34. So that way we can go ahead and position that smart motor to point to different color names. So we're going to use that color sensor to detect between two different colors. And then we'll use that servo motor to point to those different colors based on the feedback we get. And also we'll program the smart motor to do the same. So let's jump right in. I'll probably record this video into two parts. So this is part number one. All right, so in this activity, it says you'll use optical sensor to control two motors. You'll start by moving the 3-wire servo motor, which has 100 degrees of rotation, from approximately negative 45 degrees to 55 degrees. It asks to create a pointer mechanism, but what I ended up doing was I just cut mine out of cardstock. And so you can go ahead and see my setup here, which is not typically a classroom setup, but it is going to work for what we're doing today. And so one of the issues I had with my VEX servo motor, you can see the remnants of it here. Let me go ahead and put it on the screen for you. Is that it burned out, and unfortunately I didn't have another one handy. But thankfully, I did have a servo motor from one of my Arduino kits, and you can see me pointing to it here. So I was able to plug that in and use it the same exact way. And so imagine, if you will, that this right here is a VEX servo motor. Okay, we'll be programming it the same way. So anyway, let's go ahead and take a look at what they want us to do. So create a pointer mechanism. Going back to my setup here, I've got my pointer mechanism here. Again, I made it out of cardstock. You could make yours out of VEX, similar to what you saw in that image. I have my VEX V5 brain. I've got my battery kind of off in that corner there. I have a smart motor here. I've got my vision sensor, and I've got my distance sensor. For this activity, we won't be using the distance sensor, but I have it here set up anyway. Okay. Also, we're going to be playing with some LEDs, and I will go ahead and show you the LED setup. I'm using some standard LEDs just because they're a little bit brighter for what we're doing, and so you can see them activate a little bit more easily compared to the VEX LEDs, which you are more than welcome to use. And so I'll show you how to connect these into your V5 brain using the extension cables that come with VEX. Okay, so let's go ahead and start by taking a look at what they want us to do. Connect the servo to port A on the VEX brain. The servo is one of the legacy components from the Cortex days. It is a 3-wire servo, and it will plug into the ports on the side of the brain. And so on the brain itself, I have ports 1 through 20 up on the top that use those telephone jack cables, and that'll connect all my smart, motors and sensors. But on the side here, I have A through, I believe it's A through H. A through H. And you can plug the 3-wire components in here. So the servo is actually plugged right into port A. And so what we're going to do is we are going to go to my V5 software, my VEX Code V5. And if you're opening this up for the very first time, it may look like this, which is a block project, and you're wondering how you can get to the text format or the text version of V5. What you can do is click on File, New Text Project. It's going to ask you what programming language. The new POE curriculum is using Python, and so I'm going to go ahead and click on Python, and here I am. So I'm going to go ahead and drag this over. So we'll do, oops, I don't want to do that. That was not my intention. Let me go back. Here we go. Okay. So What I'm going to do is I am going to set up my servo motor on V5. Right now, my V5 has no idea, my VEX Code V5 has no idea where I'm plugging things in. So what I'm going to do is I've plugged in that device into port A. And so I'm going to add a device by clicking here and then clicking on add a device. And that servo is a 3-wire servo from, again, the legacy days of Cortex. So I'm going to click on 3-wire, and then I'm going to find my servo, which is right here, staring right at me. Then I'm going to go ahead and select where I've plugged it in. Again, I have options A through H. So I plugged it into port A. So at this point, I can go ahead and give it a name. I'll just leave it as servo A, meaning I have a servo plugged into port A. I'm going to click done. And at this point, I can go ahead and click on this again and get back to my code. Now, what I've done is I've given this program a new line of code that you don't see. If I click on this plus sign here, it expands all this code. You can see it jumps from line 1 to 15. So here in line number 9, by clicking on devices and adding a servo, it went ahead and added a line of code in Python for our program. Okay, so this is saying that I've got a servo connected to my brain in the 3-wire ports in port A, and it's got a name of servo A. So let me go ahead and exit out of that. Let's go back to our activity. It says, let's go ahead and under begin project code, add an instruction from the motion category to set the servo to its lowest position, -45. So what I'm going to do is I'm going to go over to my motion category, and notice on the left-hand side, you have all these lines of code that we can easily drag and drop from different categories, whether that be motion or looks, meaning I can, maybe print something on the screen, on that LCD screen, or certain events that occur, or control. If this is where I have my if statements or while loops or my waits. Sensing, if I've got some sort of sensors set up, I can go ahead and I'll see those lines of code accessible here. If I want to create variables, create functions, etc. So right now, what I'm going to do is I just want my servo to move. So I go to motion, and the only thing I see in motion is one line of code, because the only thing I have set up on my brain right now is that servo. So I only get servo motion options. So I'm going to go ahead and drag and drop this. And it asked me in the activity to set it to its lowest position of -45. So going back to my VEX Code V5, servo A set position, and I'm going to go ahead and change this to a -45. Okay. So I'm going to go ahead and take a look at this. I can build it. It says, would you like to save your project? Click OK. I'm going to save that as 423. What is this title? 423 moving with color. 423 moving with color. All right. So I've got that saved. I'm going to go ahead and at this time, I need to turn on my brain. So my brain is off at this time, so I don't have the option to download or run. So I'm going to go ahead and mirror my screen so you can see what I do. Is I'm just going to come over to my V5 brain, and I've got this power button right here. I've got the battery plugged in, so I can go ahead and press that power button. And you can see that VEX is coming on, and I have the ability to now, going back to my VEX Code V5, I now have the ability to, let's see, no brain connected. Oh, my USB cable's not plugged in. There we go. So let me go ahead and plug this back in. I'm gonna have to slide this over just a hair. Maybe I can get to it. Sorry, battery, you gotta move out of the way. There we go. Okay. Took a little playing around with, but I got that connected. Let me reposition my iPad here so you can see it. All right, so now that I got my V5 brain connected with the USB cable, I can go ahead and I see the option to download it. So I'm going to hit download. And if I have no errors in my program, it downloads successfully. If I have an error, so let's suppose I do this, Servo B, and hit download. It says an error has been detected. Please check the error. So I click OK. I go down to my errors here and I see undefined variable Servo B on line 29. So I come up here and I say, okay, well, I've got a mistake because I don't have a Servo B. I have a Servo in A. So I download that again. Download process is able to successfully complete because I don't have any errors in my code. So now what I'm going to do is I'm going to go ahead and hit run. And there it is. It's all, went to a home position initially. So you saw the arrow move. But after that, it went quickly to -45. Okay. So the servo positioned, that's all this program is doing. So nothing too wild and crazy here at this time. So let's go ahead and go back to my activity and see what I want to do next. So we are going to rotate it from -45 to then 55. And so it says, check your code. So I did that already. Let's go down to step number 7. It says, check our code here. We're going to, after the set position instruction, add a 1 second wait, then instruct your servo to move to its high position of 55. So we're going to add a 1 second wait and then make it go to 55. So let me go ahead and add a wait. That is under control, I believe. We are going to wait a second. And then we are going to set position to 55. So I'm just going to copy this line of code and paste it. And I'm going to change this to 55. Okay. Let me go ahead and download this. I'm going to run it. All right. And you saw it go to like a home position initially, and then it goes to -45, and then it goes to 55, and really that's all it's going to do. So there's -45, there's 55. There's -45, there's 55. And to get it to repeat, I have to keep clicking. I don't know if you noticed my cursor. I have to keep clicking run because my program just ends at the end of that. So from -45 to 55, and that's all it's doing. Okay, I have to keep clicking run. Now, if I want it to continually repeat, that's where I can go ahead and insert a while loop into my program. And so I'm going to hit enter. I'm going to drag this while loop over here. That's going to ask for some sort of condition. If I want it to repeat indefinitely, I can go ahead and change this to true. And if my condition is true, in which case I'm forcing it to be, then what do I want to happen? Well, I want all this to happen. So I believe I can just press tab here. You notice this line starts to extend. And so my while loop will repeat anything that's indented underneath this while. So what I've done is I've created a while loop, so my program should never end. It should just continually go back and forth between these two positions. What I'm going to do is I'm going to hit add another wait after this, so I have a 1 second delay before I go back to that -45. So it's going to go to -45, wait a second, go to 55 degrees, wait a second, loop back around, ask the question, is my condition true? I've forced it to be true, so it's going to go ahead and repeat. So let's see that in action. Oops, I have to download it. Let me download. Anytime I make a change to my program, I do have to download. Let me go ahead and run it. -45, 55, -45, 55 with a 1 second delay in between. And it'll run continuously until I tell my program to stop by hitting the stop button up at the top, or until my battery runs out of juice. But my battery is connected to my charger, so it should not ever run out of juice. It's going to run forever. Okay. So again, that's a little bit of an extension from the activity. All the activity wanted us to do was to have it go back and forth between those 2 points. without a while loop. So it's going to move to negative 45, move to 55, and then my program ends. So in step number 9, they want us to create a midpoint between those two values. We can perform some mathematical operations within Python and really with any sort of computer programming. And so what we're going to do is create this variable called midpoint equals, and we have to give that midpoint value or give that midpoint variable a value. To do that, what I'm going to do in my Vex V5 is if I go over to variables, it asks me to create, or it gives me the options to create different types of variables. So if I drag and drop this into my code, oops, let me get out of my while loop. And in fact, let me get rid of my while loop. And let me get rid of my indentations. Notice this line here on the side starts to disappear. There's no need for those indentations because I'm not nesting that under a while loop or an if statement. I'm going to go ahead and create a numeric variable because if I perform this mathematical operation, I will get a numeric value. I am looking for the midpoint between my two extremes, my lowest point of my servo and my highest point of my servo. So I am going to go back to V5, Vex code V5, and I'm going to, instead of having my number here, I'm going to go ahead and rename my number as midpoint. Now, what is midpoint equal to? Midpoint is equal to the halfway point between 45 and 55. And so I'm going to take those two things, add them up, divide by 2, and that's what midpoint is going to equal. Okay. Now, what I'm going to do in this next program is they want us to set the servo to its midpoint using my new variable. And so as I check my code, they have us do it at the end, but I'm going to go ahead and add it in the middle. Because what I want to do is I want to go from my lowest extreme to my midpoint to my highest extreme. If you follow the activity as is, they have you go from the lowest to the highest and then to the midpoint. And then you kind of circle back. But what I need to do is I cannot just add a midpoint position in between here. And have this defined at the end over here. So I'm going to, instead of having a value here, I'm going to add midpoints. I don't think I can. Let me double check. Download it. Yeah, error has been detected. Undefined midpoint using variable before the assignment. So I have to assign it first. And so what I'm going to do is I'm going to go ahead and take this, and it's just good practice. I always place all my variables at the top of my code. They have you place it in the middle of your code, but I've got 3 sections here and I've separated them by this empty space, this empty line of code here, which is okay. You can add spaces in between and it's not going to affect your code. So I'm going to go from negative 45 position to my midpoint to my 55, my other extreme. Let me go ahead and download this and test it out. Let me bring up my, not seeing my iPad. Let me connect my iPad to my computer once again. All right. So I should see this arrow go from negative 45 to a midpoint and then to the other extreme, which is 55. So let's see that in action. I believe I downloaded it already. Let me go ahead and click run. There it is. Okay, so you saw I'm going to hit run again. Went from negative 45 to the midpoint to the 55. Okay, let me bring this over just a hair. Guess that's as far as I can go. All right, let me make this a little bit smaller. All right, so let me run it again. Negative 45, the midpoint, and 55. Again, if I want that to loop, I can take all of this all of these lines of code and nest them within a while loop by adding, by indenting each of these lines of code underneath that while loop. But that's an extension to the activity as written, so I'm not going to do that, but it's something you could do. All right, so we can check our code. Notice what they do is they set to negative 45, they wait, they position it to 55, they wait, they define what midpoint is equal to. So they define this variable and initialize it. So they give it that initial value. and then they set that servo to that midpoint position, and then my program ends. Okay, so this is the code for step number 10, and we saw that code in action. Slight modification of the code because I added the midpoint in between -45 and 55. And yeah, so that is steps 1 through 11 of activity 423. I hope you enjoyed.